We talked about the extension settings for beams. We talked about the cutback settings at the end of beams, and the beam handle and the shape handle. So the round dot is your official sort of structural end of the beam, and then the triangular handles allow you to pull the non-structural end of the beam out. Now, it used to be that on these open web steel joists and previous versions of Revit, dragging on this non-structural handle here would allow you to lengthen the seat. Now what you have to use are the extension settings here. So if I put in values here for the start and end extension, that allows you to extend the joist seat by a specific amount. So if you're doing a cantilevered, say a parapet, that's going to hang out here. So you're not going to, run any heavy-duty structure out into your roof overhang. You're just going to use a longer joist seat. I think you can go 2 or 3 feet with extending your joist seat, depending on the joist. So if you need to do that, just bang in the number here into the start and end extension values. In the notes, it talks about concrete beams. If you use a joint geometry with the slab, I'm not going to demonstrate that. What I do want to show is how in your floor plans, if you need to see the structure over, don't forget about the overlay settings in your view properties. So looking at the properties of your view here, if you take the underlay setting and you turn it on, underlay the same view, same level as you're looking at. Level 1 plan view, turn your underlay on for level 1, but instead of looking down, look up. Now, you can see that there's that one gray line that's appearing there. This has to do with the level of detail. So let's go to the second floor plan here. There's what a structural beam looks like in plan. Big, heavy black line. That's how structural engineers' drawings look. Now, if you set your level of detail away from coarse and you go to medium, Revit now shows the physical sizes of those structural members. So that coarse single line representation is a desired feature by structural engineers. Now, you might be thinking, well, hold on a second here. I want to show my walls at the coarse level of detail. I don't want to see all the material layers. So here, if I drew a wall assembly up here, so I'll just grab something that's got some stuff in it here. So you can see I've got a wall here. I want to see the width of my beams, but I don't want to see those material layers because at 1/8 of an inch to a foot, other levels of detail don't make sense. So I want my coarse level of detail. So what do you do with the structure? Well, in your visibility settings for the view, go down to the structural categories, your columns, down to your trusses, all those categories. Now, what we're going to do is we're going to override the detail level. So instead of being coarse, like the view, we're going to set the level of detail to medium. So in this view, we're overriding the level of detail for our structural objects so that we will see their full width, and yet, at this scale, maintain our 2-line representation of our assemblies, which is appropriate for this scale. Going back to our first floor ceiling plan then, to get that stuff to appear or to get the, so again, a view range situation here, our view range isn't enough for us to see the next floor, or we need to set our level of detail correctly here. Might have to go a little bit more. I'm gonna go up another foot. There. Oh, I've probably got a slab there or something. I don't know what's going on. It's level 1. So on your floor plans, to show structure above, use that underlay of the same floor. So you're in level 1, so your underlay is of that same floor. But get it to look up. And now you can see that structure above. So if you want to draw where that structure is, you've got two choices. You can use detail lines, and just draw in where that structure is. Or you can use the line work tool, right? So using the line work tool, I can just simply pick the edge of those beams, and they will continue to appear even when I turn the underlay off. Now Revit's WYSIWYG, so of course we don't want to see all this structure sitting there. We just want to choose particular beams that are important just to show them here in this floor plan or ceiling plan. So note that when I turn the underlay back to none, those lines are still present. And if that structure moves around for whatever reason, those lines are moving around because this, of course, the line work tool does not create additional geometry. It simply changes how the edges of geometry appear. So normally, those beam edges wouldn't be here, but because we've hit them with the line work tool and made them dashed, they will continue to be so until you use the line work tool again and choose by category to get rid of those dashed line representations. You notice that Revit does not give you any indication that it's going to do anything when you pass your cursor over it. Just click it. It goes away. So that is a little trick right there. We're going to move on to beam systems. Now, what I am going to do here is I'm going to show you how you can quickly put some joists between two beams. So in this case, I'll stick with the idea that we're doing a open web steel joists and then putting a floor on top of it. So I'm going to run my joists lengthwise here. So I'm going to drop these two beams down by their Z offset by minus 2.5 inches. So my joist seat can sit on that. And I'll worry about the floor in a bit. So as long as my two joists are at the same level, that's where we are in the plan. So I'll do this in plan. So there's the area that I'm working. Now again, think of view range. If you're working on the floor plan and you're not seeing anything, and like you want to be able to see those joists, because we're going to need to work with them in a moment, not those joists, these beams, because we want to work with these beams in a moment to put the joists across between them. Go to your view range, and right now Revit is only looking down to the floor level, and the only reason that we're seeing those joists below is because there is an underlay turned on right now. And if there was no underlay, we wouldn't be seeing anything. So you can see nothing. So you either turn on the underlay or go to your view range. So this is under the level 2 floor plan. And make your bottom and view depth, minus 1 foot. That will be enough for you to look down and see that structure that's down there. And I think in this view, I must have already done the override with the so you can see here I've done the override with my structure, overridden it to medium, so that I can see the physical width of those beams. So beam systems. So on the structure tab, there it is right there. So the beam system is a means by which you can create a floor joist or roof joist layout quite quickly. So let's activate the beam system tool. Now, if you have structure that completely fills a bay, and Revit can sense that there are joists at the same, or not joists, but beams, all the way around in a certain space, Revit can automatically insert a joist system. You can see it's doing it here. It can do it in this bay because there's beams on all 4 sides. It can't do it here because it's open on this one end. So you can decide if you want Revit to automatically put your joists in, or whether you want to sketch the boundary yourself. Now, before you get there, you have to decide, number one, what structural member are you going to use as your joist? So we've already got an open web steel joist here that we loaded, so we're going to use that K-series joist. Only model your joists if they're significant and they're going to be seen in section, or they're going to be part of the coordination process, or they're going to be exposed. A 2x10 joist system in a house meets none of those guidelines. You're like, well, I'm going to put in a 2x10 joist system so when I cut through my floor in section, I'll see all my joists. Good for you. Don't do it. There's no point. It's just one more thing to manage, and you can do it with 2D detailing, and that's good enough. There's no reason for those minor joists to do that. But if the joists are exposed and they're significant in depth, and also you might be looking at coordinating. You might be trying to pass a duct or some plumbing through the webs in those joists, and you want to see where that lines up. That can be great for coordination purposes. So grab your joist there, determine the general spacing for those joists, the justification for how these joists will be laid out. Is it going to be on one side or the other side or centered? You can just leave it at centered for now, pick your spacing, and now we're going to choose sketch. So this is like sketching a floor, but you're sketching a closed boundary that indicates where the joists are going to go in this bay. There's pick structure for structure that's already here. So there's a beam, there's a beam, there's a beam. This is a non-structural wall. So it means we have to manually draw that final member. So it's like a floor sketch or a roof sketch, closed, non-intersecting. Now have a look on the screen, and you've maybe never paid attention to this before. One of the sketches will have a set of lines on either side of the pink sketch line. That is telling you the direction joists will span within this bay. If you want them to go the other way, there is the beam direction tool. So you click that, pick one of the sketch lines, it doesn't matter which one, to indicate that you want the joists aligned with that side of the bay. So again, there's your beam direction tool. Pick which direction you want your joists aligned. Now you can also set the elevation of your beam system. So again, if we were using a 4-inch slab, we drop this by -4 inches so that when those joists go in here, they'll be dropped 4 inches as soon as we put them in. Hit finish, and there's your joists. You may not want Revit to tag them when they go in. When we're using the beam system tool, there is a, well, that's weird. Tag on placement wasn't selected, and yet it put them in anyway. I don't know, I'd have to go back and look at the video and see if this was selected like that. Whatever. Okay, so let's go and look at this thing in 3D. There's the joists that have been added. Now, if you want to select the beam system after you've placed it, you can do it in plan or you can do it in 3D. Put your cursor kind of near the boundary of the joists, like the edge where the pink lines were, and hit the tab key until it highlights. Now you can see it doesn't look like it's going to highlight for me here, so I'm going to put my cursor over one of the joists and tab it once. So there's hover tab click working for you. Again, cursor over one of the members in the beam system, hit the tab key once, it pulls up the boundaries, and now I can left click, and now the beam system is selected. And I can go back up and I can either edit the boundary, or here I can change the justification. So this will adjust where the beams are sitting within the width of the the beam system. All right. Now, okay, so are you in plan? Okay, put your cursor over one of the members, just hover it over the end, not right at the end, but along its length, and hit the tab key once. Just tap it. Well, it kind of is. Oh, okay, all right. All right, so now you can left click it and away you go. Now, if you need to, for whatever reason, now let's say that you're going to have an opening in here, and you want to change the location of one of the joists in the beam system. Now you notice that you can put your cursor over one of these things in 3D or in plan and select it. Now I'm not tab selecting it, I'm just selecting it. And when you pick one of the members in your beam system, you can see that there is a pin icon on it. So now you can unpin that joist, and you can delete it, or you can change it to a different kind of structural member, or you can move it, whatever you need to do, or you can copy it. So I'm going to move this one. And then I'm going to copy it. So I've doubled up my joists on either side because what I'm intending to do here is to run a steel channel the other direction. I'm going to build an opening, right? So you've got your header joists on either side of the opening, and then you draw the structure that's going to go in the other direction for an opening here, say an elevator or a shaft or something of those lines. So when you pass your cursor over the beam system, it shows you where the beam would have gone if we kept it according to the pattern. And if you realize you've mucked it up and you want to bring that thing back, you can reset the system. So we're on the bottom of page 3. So I'm just going to, there's my beam system, it's been highlighted. And if you go and choose Edit, while you are in edit mode, there's reset system. So any of the changes that you made to the joist's location, any of the changes that you made to the type of structural member that you used in the beam system, Revit will reset it so it matches all of these parameters: fixed distance, fixed spacing, using this structural object. So you'll notice that the copied joist I have over here, Revit moved it back to its original location and left the copied one where I had it. Now with beam systems, you can tab select them, and then of course you can change the member that's being used for the beam system. But what you will notice is that beam systems, when you look at its properties, you'd kind of think, hey, I should be able to create a beam system that's 24-inch open web steel joists, 6-foot spacing. Like it's a type property, right? Like a 2x10 floor or an 8-inch concrete slab. Beam systems do not have type properties. So this means that all of your beam systems are a one-off. So when I go to the next bay here and put my beam system in here, I'll have to confirm the settings again, and that actually makes sense. The reason being that when you look at the layout of a building, very commonly the joist configuration changes from bay to bay, and it's really easy to change the configuration quickly by just tab selecting, so you get the dashed line around the outside. So whenever you're trying to look for the beam system, it looks like that. A series of dashed lines where the joists are, and a series of dashed blue lines around the perimeter. So just tab select those beam systems, And that's where they are. Okay, let's move on to page 4 here. We're going to talk about placing beams on work planes. So mostly what we've been doing here is we've been putting beams in plan or beams in 3D. If you're doing more expressive beams, you will probably want to put them in using some other method. Now, if we look on page 4 at the top here, you can see we've got some more expressive beams. How do we create geometry like this? So if we've got a curved beam that we want to build, the best way to do that is in elevation. And what we need to do is we need to tell Revit that we need to put that beam typically centered on a grid line. So here what I'm going to do is I'm going to put a curved beam on this grid line 5, and I'm going to do that using my north elevation. So here I'm going to go to my north elevation. I'm going to set my level of detail to medium so I can see my structure more clearly. So before I use the beam tool here, or even when I use the beam tool, Revit's going to ask me to set my work plane to something. So when you're working with structure, you want to use a work plane that is perpendicular to your direction of view. So you want to be looking at the side of a work plane and then place your beam in that work plane that's perpendicular to your direction of view. So either way, you can choose set work plane first and then go to the beam tool, or you can hit the beam tool and then Revit will ask you what work plane you want to put this thing in. So grid line 5 for me, because that's perpendicular to my view. And now I'm going to go grab a glue lam beam. So if you guys remember those old Safeways that we used to have 20, 30 years ago, they had big, huge curved glue lam beams. So I'm going to go to load family here and go to my Imperial Library and down to structural framing. So inside structural framing, I'll go to wood. And there's our glue lam western species. So choose your glue lam western species in the wood folder under structural framing. So I'll go down and get a beefy one here. So I'll go get, let's see, 42 inches deep. That sounds good. 8 by 42. So there's my new glue lam beam. So I'm drawing it on my grid 5 plane. So now I can do even a spline based beam. Now that'll break the bank really quickly. So I'm going to stick to doing a curve here. So yeah, I'm going to turn off 3D snapping to make sure that it stays in the grid 5 work plane. So I'll draw a curve here. There's the start of it. And I'm going to keep going here. There we go. Now, when you put beams in, Revit will help you get tangency between them, but it'll still draw them as 2 separate beams. And it'll join them together nicely so they fill it like you're seeing here. Like it's a pretty good job. So now when we look at this thing in 3D, there's our curved beam. I'll just turn on shading here so it's a little easier to see. Now, if you want to use this beam and put it all the way across your roof, you don't have to draw the beams again. You can do it in 3D, you can do it in your roof plan, whatever floats your boat. I'll go to my side view here using the view cube, and I'll crossing select the beam, and then you can just copy it multiple sideways, right? So I can just drag it across my screen and put those things in at whatever spacing the engineer says we can get away with. So notice how you can use your 3D view for doing sort of precise plan style or elevation style manipulation. So just click on one of the faces of your view cube. That's like working in elevation, and I can copy straight sideways. Same thing with plan. Click the top of the view cube You're looking straight down on your project as if in plan, and you can make plan style changes with precision. Those of you who work with wood structure, and a lot of us do, if you need to make a rake, a cutback on the bottom of your beams, I'm just going to bring up here the method by which this is done. Revit has its own structural families here that are made. We realized it was going to be a pain in the butt to try and get these cutback beams to, change the extrusion so it's got that cutback built into it. So what we did instead is we have voids that are in those families that we can turn on, and when we hit the checkboxes to turn them on in the family, it brings these voids in so that they cut the solids. So that's just a little introduction to how this is going to work. Later when we do the exercise together, you'll see how those voids work. I'll show it off. Now let's go over to the next page here, talking about braces. So braces allow you to put structure typically from a column up to a beam. So there's your, where is it here? Brace tool. So maybe it's an HSS tube or something like that. So with your brace, go and choose which structural member you're using for the brace. Typically you will 3D snap with your braces, and you should be able to snap onto a column or a beam and connect the two together. Revit does now have connectors, so you can define the connection, the actual physical connection that you would see here on your screen between your beam and your column. That's probably a whole nother class worth. I'm not going to get into that tonight, but that's how bracing is done. Now for the metal deck, so we talked about in the section that I had up on the screen there, so this is under structural floors, metal deck profiles. If you want to use those in your project, so that's a concrete floor with a metal deck underneath it, you'll find them here in the floors. Now it doesn't matter whether you use an architectural or structural floor, so we'll just use the regular architectural floor. It still shows the structure. The difference between an architectural floor and a structural floor is this. That checkbox. That's it. So here, I'm using the architectural floor, structural is unchecked. Okay. Go back to floor, choose structural floor. Same floors, it's just that structural is checked. That's it. So what should you use? Well, stick to using the architectural floor, because otherwise that turns on some structural analysis features inside your model that does create a little bit of extra overhead for Revit to think about. So unless you're an engineer and are going to get your model analyzed by an outside piece of software, just avoid using the structural floors. Okay, so in our floors here, if you folks go to 3-inch concrete on 2-inch metal deck, in the architectural template there is already a floor object, a floor type that has this set up. So when you go into the type properties, we're going to look at the structure of this floor system now. So here's the list of materials in this floor. So the secret sauce in creating a metal deck floor type is this one right here, structural deck. Now you may have a whole bunch of projects that don't list structural deck as a potential function in your project. This structural deck function will only appear if you have a metal deck profile loaded. Let's go talk about that for a second here. So, Metal deck profiles. You guys know about profiles. They're used for handrails, they're used for fascia, they're used for all kinds of stuff. Profile families are also used by floors in your project, and they're loaded, or they're located in the Imperial Library under the Profiles folder and Metal Deck. So inside the Metal Deck Profiles folder, so there's the path right there, Imperial, Profiles, Metal Deck. Any one of these, if you load them into your project, will enable this Metal Deck function in your floor assembly. So here's the thing. You specify the maximum thickness of your floor. So we've been talking about 4-inch concrete. So now we have 4-inch concrete, so I need to change my designation here. So it's going to be 2 inches of concrete on 2 inches of metal deck. If you need your metal deck to have a different thickness, that's in the Profiles folder here. So if we go down to Profiles, and then I guess it's this one here. So in here, you can change the thickness to 1.5 inch. So I'll just rename this 1.5 inch deck. So you can see in here, change the HR value. So now we have 1.5 inch deck. So now when I go back and put in my floor here, I'll just draw it in this bay. You could draw it so it goes across the entire floor plate, but that may not be the case. Now have a look at the direction of the joists, and now you can see that the floor has a span direction setting which we never cared about before. If it's a wood floor or a concrete floor, do we care which way the span direction is in those cases? No, we don't care, but we do now. We want the span direction for our floor to be perpendicular to the direction of our joist, because that's the way the deck is going to be oriented. So when you're doing steel construction and you're using metal deck with one of these floor types that's got the metal deck profile built in. Now, let's cut a section through this. Now again, this is our section. At the coarse level of detail, you don't even see the webs in the joist. So even if I change the scale, it doesn't matter. Still not seeing that geometry. It's not until I go to the medium level of detail that I see that geometry. And in fact, at the coarse level of detail, look what the floor looked like. Nothing. When I switch to the medium level of detail, now we can see the undulations in the deck. How about those thread rods on the joist? Doesn't that look like it can carry some tension? Look at the fine level of detail. Now we actually see the rods in those open web steel joists. So the difference between medium and fine, you'll notice that with your open web steel joists and other structural objects as well. So once you get down to the smaller scales, where you really begin to notice that there's something missing, set your level of detail for your structural objects to fine. Now you're looking at this floor here and you're thinking, wow, Revit is modeling the flanges of the deck. Like, well, if I go for a little 3D view underneath that, what am I going to see? So I'm down here, my first floor plan. Here's the bay where we're putting this stuff in. So I'm going to put a camera in. Don't do this. Just watch me do it here. Just going to prove something. Here's my camera. I'm looking here on the first floor. I'm going to set my level of detail to fine so I can see all those webs, turn on shading. What the heck? Where are those flutes? Just going to walk around here. Do you guys see any flutes in that metal deck? I don't see any flutes. What the heck is going on? Well, what's going on is that Revit is doing these things in 2D in this view. It's not 3D. Another thing that is not 3D, I don't know if you guys have ever thought about this, but you know all these different material lines that you see in the wall here? Fake news. They don't exist. What you're seeing here are 2D lines, 2D hatching that the software puts in to show where all those different material layers are in the wall. And that same sort of chicanery is happening here in section. Revit is drawing the undulations of our slab, but it's not modeling them. So if we cut a section parallel to the flutes, so I'll do that again here. So here's my section. And now I'm going parallel to the joists. Let's have a look at this one, and we'll make our level of detail fine here. When we zoom in on our slab, you can see there's this line here. So we're looking at the side of the flute, so we're seeing the bottom of the metal deck there, right at my cursor. Concrete above, metal deck below. But it's just in 2D, so just keep that in mind. So with that structural deck, it's great. It shows the contractor what's going on, but it's not actually modeling those conditions. We're going to move on to foundations. We're going to look at two foundations, really, the two styles of foundations, wall foundations and isolated. So first of all, isolated, that's really, it's code for pad footing. So an isolated footing is just a pad footing. So to get at this stuff, you go to the Structure tab. There's your isolated footing tool. So typically when you get your structural engineer's drawings, they'll have the width, the plan dimensions that they want for the footing, as well as its thickness. So when you click the isolated footing tool, Revit will say you don't have one, so you need to load one. So yes, we're going to load one from the Imperial Library here, and it's down under Structural Foundations. So go to Insert, Load Family, go down to the Structural Foundations folder, and we just want the rectangular footing. There's other kinds of isolated foundations here, but we just want the rectangular one. I'm not sure if this is exactly good naming on Autodesk's part, because you think of a rectangular footing and you kind of think, well, that's what goes underneath my wall. But in this case, this footing, rectangular footing, it's in the isolated folder, so it's not in the isolated folder. Yeah, that's what makes it so confusing. So when you go down to Structural Foundations here, do you see isolated anywhere? No. So that's your pad footing. It really should say rectangular pad footing, but whatever. Open it up. And now you're going to end up with this ridiculously huge pad footing. So typically a pad footing under a column might be 3 foot by 3 foot in dimension and a foot thick. So go into our type properties here, and I'm just going to make it 3 and 3 and 1 for thickness. So I've loaded in the rectangular footing, and I've gone into its type properties so I can make it a regular size. I'll rename it as well, so I'll call it 3 by 3 by 1 foot. 3 foot, 3 foot, come on, 3 foot. There, right? Because you want the name of your pad footing to match its dimensions. There we go, 3 by 3 by 1. Make all the different pad footing sizes that you need. as you go along. Hit OK. And now there's an option here to put it at a column. So typically when I'm doing a steel building, I'll flip the building upside down. That way, you know, all my floors and stuff, they're above. And I can see my columns poking down. So I hit at columns, and I'll pick all the columns that need these footings. So hold down the control key, and you can see it's going to start putting these pad footings in there at each one of these columns. Hold down the control key, and you can do a bunch at once. There. Now, because you've done the at columns option, Revit attaches the foundations to the underside of the columns. Revit gives you a little note here. So if your columns are going 1 foot below grade because you're going to pour your slab, so it's completely over top of the footing, so typically we'd run the column down below grade by a foot, and then the pad sits down at the column, and then they pour the concrete in, and the concrete comes in right around the base of that steel column. Revit's just warning you that it's moving these foundations down to the ends of the columns, and that's great. So there we go. You've got our pad footings sitting in there. Those are quite straightforward to put in, but you have to load them in the first time you use them. The next footing is the wall footing, the foundation. And when you activate this tool, this is sliced bread. This is pretty awesome stuff. So for your foundation walls, you can put them in. So again, choose the dimensions of the footing that you need. So here we've got a 3 foot wide footing, 1 foot thick. Just pick your walls, and it puts the foundation underneath those walls, like very fast. It's a great tool. Sometimes you'll run into situations where just with the configuration of your walls, the footings are doing things that you don't want them to do. So what I'm saying is there will be times where Revit's wall footing tool is going to be such a pain in the butt for you that you shouldn't use it. What do you do in that case? Just use a floor object. So if you need a 12-inch thick footing and the wall foundation tool is making you insane, and it will, because sometimes the way that they join at the corners and the way they overshoot, at some point it's going to make you nuts. So at that point, don't use it. Use the floor tool instead. So if you need a 12-inch thick footing, go into your floors, go grab some 12-inch floor and turn it into 12-inch concrete. 12-inch concrete floor. Use it as a footing. It's going to look like a footing when you cut it in section. Who cares, right? So at some point, go ahead and use those floor objects as your footings. Okay, that's page 5. So let's talk about a few little just a few tips here about doing structure. And in fact, what I'm going to do here is we're going to go in and talk about slope structure for doing tilt-up steel. So in the Session 3 folder, you folks should see tilt-up and steel framing. Go ahead and open that up. So go to the J drive, share out, BLDG 2805 Session 3, and go and find the tilt-up and steel framing file, which I'm opening up right now. So this is a pretty common and admittedly boring form of construction. It rains a lot out here, so getting the water off the top of the building is important. Some of you might have dealt with tapered insulation, tapered roof insulation, where the insulation comes at a greater thickness at one end and it gets to a lower thickness at the other. So you're tempting the water to go to a certain location on the roof. Tapered insulation is expensive. So a lot of projects, when they're talking about it, they talk about tapered insulation for about 30 seconds. And they're like, nope, we're going to slope the structure because tapered insulation is too expensive. So sloping structure sounds great. Now you got to model it. Not so easy. So here's a situation here. So when you folks open it up, you can indeed see that the open web steel joists at the perimeter are at the same height. So in the tilt panels, they form little pockets with a steel shelf. I'm sure that's not the right word, but it's an embedded pocket. And there's a steel plate in there that the open web steel joist comes in and sits on, and then they weld it onto that plate to hold it in place. Now, of course, we're not welding the pocket, but we've got all the open web steel joists at one elevation there. On the inside, we've got columns here where the structure slopes down to the column from the outside wall. Then it slopes up to the next column, and then down to the next column, and then finally up again. So there'd be a drain at the low points of the roof, and we're just going to get everything to slope into those drains. And we need to slope the structure as well. And if we look here, you can indeed see that each one of these joists is following the undulations of that central beam. Now, I didn't go through and put in the two different offsets so that the seats would be sitting above the beam. I could have done that, didn't bother. But I wanted to show us how you can use 3D snapping from the wall at the edge to the beam at the center. So what made this easy was the fact that in my wall, if you're wondering what this is, it's a little HSS tube. I had made it so it was just 1 inch by 1 inch. Now why did I make it so small? So when you cut through it in section, you don't see it, right? So I got in my roof plan here, if I cut a section through my building and I make my section here, nobody notices that there's a 1 by 1 HSS tube in here, and I'm not making any notes about it. The reason I put it in there was so that when I was modeling this, I could snap to that HSS tube. So it's at a height that allows me to get my slab above it and my insulation and everything, so that I put the HSS tube down low enough, that's low enough to do what I need it to do, and then I 3D snap to it. So when I'm putting in my joists, I'm putting them all in one at a time, unfortunately, and I'm 3D snapping from that HSS tube to my center beam, snap perpendicular. So my joist is now following exactly how the structure is falling, sloping. So in my roof plan, there's that joist I just put in, that one right there. Now, how many people in here are CDO? You know what I'm talking about? Of course you do. It's OCD, but it's alphabetized like it should be, right? So if you're OCD, you're thinking, is this joist perpendicular? Probably isn't. I did do a snap perpendicular, but it's probably not. So what you can do is you can use a detail line, and with the detail line drawn straight up on the screen, here's our course level representation of our beam that's right at the center of that joist I just put in. I can use the align command and align my newly placed joist to that detail line, and now the OCD part of me is happy because my joist is right on that line, and of course I may have a specific spacing from the structural engineer. And so unfortunately, with these sloping structure projects, you end up having to model each one of those joists individually if you really want to be accurate with how the structure is being modeled on the roof. I think on some projects this wouldn't matter. There's other projects where it would. So I had a project where there was coordination and there was limited ceiling heights, and I was like, screw it, I'm just going to model it. But if there's reason to do so, go ahead and go for it. So there's a sloped structure, HSS placeholder, placing columns first, editing structure after placement, so that's using detail lines just like I showed you, modeling it roughly in 3D just to get the members into place, and then use those detail lines and the align tool and align that structure exactly into place. We're going to be talking about the massing tool set next week, and you can see this gray toned thing in here. This is going to allow us to skin the roof right onto this plane, which is defined by following the tops of these joists as they warp, because each one of these joists is at a slightly different slope. Trying to model that roof with the regular tools, impossible. Using the massing tool set, it's actually a total piece of cake. So for these super stupid, super garden variety tilt-up structure buildings, they do provide some geometric complexity. Now, last page, page 7 here, we talked about levels of detail and all that good stuff, so that's all fine. What we're going to do now is we're going to go through this wood frame exercise, and we're going to show how to work with the structural tools for doing sort of an expressive wood structure, and talk about some ways of drawing things like timber beams to work with the planes of a roof. So if you folks want to open a structural wood framing exercise here, that's in the session 3 folder. We're going to work on this together. Now I'm going to show you guys the end goal here. So the model will show what our goals are here. That's what we're going to create right there. So we've got basically a heavy timber framing project where we've got some valley beams in the center, and we want to bring our common rafters down to bear on a valley rafter. So this is where we're going. This is where we are to start. So we're going to get to that end goal now as a group. All right, so this is page 8 in your notes. And again, the file is called Structural Wood Framing Exercise, and that's on Share Out, BLDG 2805. Okay, here we go. Go to the Structure tab, and we're going to use the Beam tool. And it says used a 5.5 by 15 wood beam from the properties palette here. So 5.5 by 15 right there. 5.5 by 15. So it says on the options bar, choose 3D snapping. It's probably checked already, no big deal. And what we're going to do is draw the beams like this, from one post clear down to the other end. We're not going to worry about spanning from post to post. This is an architectural thing, not a structural thing. So there's one. Here's number 2. Finally, here's number 3 going across, and 4. So you should have 4 of these things. If you want to see it in color, just go down and switch to shaded so you can see it in color. All right, step 2. After the beams have been placed, select them all. So hit escape and then control click the 4 beams, 1, 2, 3, and 4. And now it says blah 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 blah. Set the start and end extensions to 4 feet. So those are here. Start extension, 4 feet. End extension, 4 feet. Now, folks, these parameters here, the start and end extension, the Revit developers are not consistent with how these functions are used from family to family. And in fact, you will find some families where this extension feature isn't available at all. And we showed that before with the steel beams. So there, that's what it does. Now, it says, check the boxes for notch end 1 and notch end 2. These ones right here. Now, those boxes were created by me because what I have done is I have altered this family, this beam family here, so I can get these rakes created on the bottom of these beams. I'm just going to take a moment here and talk about these things, these beams, so you can understand how they work. We're going to be talking in more detail about beams later on in the course, but here's the deal. That rectangle that you see right there is the out-of-the-box shape of one of these beams. Now, some years ago, once the structural tools started being released to the design community, we were looking at these things and going, oh cool, we've got structural objects now. I wonder if we can shape them at the end so we can get a little bit more of an expressive end on our beams. And we started playing around with it and trying to change it, and it was like, oh shoot, it's a sweep. How are we going to do that? So eventually, like, couldn't figure out how to make geometry that we could change the end shape to do a cutback like you see right now. So what we discovered is that if we put in a void at the end here, we could make the void cut back the end of the beam. And you can see it happens on both sides here. So what those checkboxes do that you see in our model here they move the voids in so that they carve those beams. When you uncheck these boxes, it moves the voids away so that they don't cut the beams. So the out-of-the-box beams don't have these. And you folks are welcome to take those beams that are in that folder and use them in your own practice. Step 3, open the south elevation view. Right-click on one of the beams that we just placed. Right-click. Select all instances in the project. So right-click, select all instances in project. There's all the beams. And it says move them upward by their entire depth so that they sit on the columns rather than being embedded in them. So there's the move command. And move them up. There we go. So now in 3D, the beams are sitting on the columns. That's where we are so far in 3D. So we're still in the south elevation. So we're going to draw now that beam that you see at the bottom of page 8 in that elevation view. So that's our beam at the end of our gazebo here. Architecture. Set work plane tool. So there it is there. Architecture tab, set work plane. So we're setting our work plane before we get going. It's already set to grid D, so that's good. So yay for that. Structure tab. Beam tool. Now instead of this big 5.5 by 15 wood beam, we're going to use a 2 by 10 full sawn. So if you buy lumber from a custom mill, you can get it in full sawn dimensions. So it's a full 2 inches thick by 10 inches deep. So this is happening. So it says, ensure that 3D snapping is unchecked on the options bar. Chain is turned on. Now draw the beams in from the eave to the peak and to the other eave, all in 3 clicks. This is what we want to do. Wait, it's not snapping. Why? See, I can snap it with 3D snapping, but when I uncheck it, it doesn't snap. So that's lame. Why won't the software work with us today? Well, this has happened every time, and I can't quite explain it, but when you go back and use the beam tool again, see that? It's working now. Why wasn't it working before? I think Revit just has this need for me to bitch at it every time that I do this course, so it'll do it. So you folks, well, first time you'll try and do the beam tool, and it won't snap to it. So just draw a couple of beams in your view, hit escape, delete them, use the beam tool again, making sure that you're using a 2 by 10 beam, and now it's magic, it snaps. Make sure 3D snapping is turned off. Go from the eave to the ridge to the eave on the other side. Voila. Now, after placing the beams, we're going to edit the notching checkboxes here appropriately so that we get the cutbacks at the appropriate end of our rafters. That's what you want to end up with. So have a look at the cutbacks there. That's what you want to see. So when I'm building expressive structure like this, often it's based on 2 things. We have a roof with a given slope. So we've got a roof design that we've built. And so what we want to do is build the structure that's necessary to support this roof. So it's a wood deck. So it's a decking style roof with the little flanges that interlock. So those are going to be built sitting on top of these rafters. So these are, I guess, purlins, you might say. And then you've got your heavy beams, which support the rafters, which in turn support the deck that's on top. So the process by which you do one of these expressive structure projects is get that roof sorted out, figure out where your column placement is, get the beams in place, and then you can start drawing your rafters on top of the roof or using the roof as a guide. Okay, step 5, open the underside of beams ceiling plan. So here right now, we're looking upwards at the roof, and we were in the south elevation. So there is the first pair of rafters that we have created. Now, if we look at this plan, we can see that the bottoms of the roof here are being truncated or cut off because of the view range. So actually what I need to do in the view range here, right now it's at the underside of beams, that level. I'm going to drop it by a couple of feet. I'm going to make it -2 feet here. See if I can lower that cut plane down so it's not cutting the roof anymore. Yes, there we go. So just by taking the view range of our ceiling plan underside of beams, adjusting the view range down so that we can see the edge of the roof. And you're going to see why this is a good idea in a moment. Okay, at the bottom of the plan at grid D, you should see the beams you've just added. Select both beams, so hit the control key there, grab those two beams. And we're going to use the copy command. So again, we know what the joist spacing already is, so we're just going through this process here. So we need 5 copies, I guess total, I don't know. So click anywhere and then drag straight up on your screen, and we want 6-foot increments. So 6, enter, 6, enter. So 1, 2, 3, 4, 5. I think that's all we need. Just those 1, 2, 3, 4, 5. Yeah. 5 copies of the beam. So really, I guess you should say in the text, 4 copies plus the original. So in 3D, this is what we've got so far. Okay, over to page 9. Now, when you think about adding those valley beams, by the way, the roof is turned off here. In the 3D view, the roof is turned off so we can kind of see what we're doing. So there's our roof, which I've just made transparent and you can see. So let's think about what we're going to have to deal with here. We need to draw our valley beam from here at the eaves up to the ridge. How could we do that easily? We could cut a section aligned with the valley, and in that sectional view we could try and draw on the bottom of the roof and make it go up there. We could try and sort that out, but it turns out there's an easier way. So in our ceiling plan here, we're going to ask Revit to draw our valley rafter right on the underside of this roof, like just glue it right to the underside of the roof. So just watch me here, I'll walk through the process. So I'm still using the beam tool, I'm still drawing a 2x10 joist, but before I draw it, I'm going to use the set work plane command, and I'm going to ask Revit to put this rafter on one of these planes of the roof, whichever one I want to start with. So I'm going to start with this one. So by using the set work plane command and picking one of those sloping planes of the roof, when I draw that rafter in there now, using the beam tool, that rafter right now is going to be glued to that face. It's right there on the underside of that roof. Now, it's kind of funky looking right now, but when you think about it, what's happening is that the top face of this 2x10 is flat to the underside of the roof. And if I keep bringing this thing around, right, it's flat to the roof. So when I go straight up to the ridge, right, but the more I drag this thing around, the more kinked over it is because the top of that 2x10 is right on the roof. Can you guys kind of, here, I'll go to 3D so you can understand it a bit better. Right, so there's looking right at the face of the roof, and yeah, the top of that 2x10 is right, there's no gap on either side of the 2x10 at the top here. This corner is right against the decking and that corner is right against the decking. They both are. But what we want to do is draw this 2x10 from the edge of the roof, the eave, right to the top on that plane. So let's do it. Beam tool. So make sure that you've done the set work plane command and you've chosen pick a plane. So architecture set, pick a plane. Pick this left side of the roof first. And now Having done that, go to the Structure tab, grab the beam tool, and draw it from eave, and you'll see an endpoint snap there, right to the peak, and you'll see an endpoint snap there as well. Hit escape twice. Now, it's great that Revit has put that 2x10 aligned with the valley. Let's get this thing vertically oriented instead of flush top of rafter to underside of deck. So select that joist that you've just put in there, that rafter, and you're going to see an orientation setting for it here. So instead of being normal, i.e. flat up against the underside of that roof decking, switch it to horizontal. So what this means is it's now going to make that rafter so the top of the rafter is horizontal. It's not tucked up against the roof on the flat. It makes the rafter, I wish it would say vertical instead, because that's really what's happening here. So that's great. So there's our rafter on this one side. Now we need to repeat the process for the other side. Architecture, set. Architecture set, pick a plane. Hit OK. Pick the right side this time. And now draw that rafter from eave up to the peak. And that other rafter is in the way, so if you're not sure, just put your cursor up there and type in SE for snap endpoint. There we go. Now, looking at this thing in 3D, where those two rafters have come together, it's not exactly perfect. If I try to use a trim command to fillet them, it gets a little better, but it's still not perfect. I used a trim command, by the way, in 3D, TR, and trimmed the two rafters together. So if they start off looking a little, like really ugly like this, use TR for trim, and then pick the two rafters, and it should clean up a bit. All right. Now, we've got one more set of rafters to draw. So we're going to go back to the ceiling plan for this here. Here's what we're going to do. We're going to take this set of rafters that we've got already drawn, and we're going to copy it up another 6 feet. So another 6 feet up. So in 3D, that's what you're going to see. Another set of rafters. Now, oh, so maybe I was right. The original copy plus 5 copies. Okay, so I just forgot to copy the set of rafters initially. We needed them. Okay. So now, what we're going to do is we're going to use the extend command to extend the rafters up against the valley rafter. So our common rafter needs to stop at the valley. So you can use trim or extend, whatever. I'll use the extend command because then I can say pick this. So you can see I'm picking the side face of my valley rafter. So I'm using the extend command. I want my valley rafters to stop at the side face of my valley rafter. So my common rafters are going to stop at that face. So there's my boundary. Click. Now I click my common rafter here and my common rafter here. Now they don't need to be notched anymore, so I'm going to turn off the notches for these two rafters. And I'll do that on the other side as well. So extend command, extend multiple, pick the inside face of your rafter. You could pick the outside face too, I guess that doesn't matter. But as long as you pick one of the side faces, not obviously the top face. There. That is where we're trying to go. So we've got our common rafters being supported by the valley rafter, just at the peak. So the last thing that we're going to do here, because there's really no point in drawing it in the other quadrants, this is a symmetrical design. So we're going to use the mirror command and mirror all of this so that we don't have to do that much more with it. Alrighty, so we're at step 10, mirror the structure and finish as shown by me. So here in my underside of beams view, what I'm going to do is I'm going to pick those beams that I've drawn, holding down the control key. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 common rafters, 13, 14. So it's going to be 14 objects, your commons plus your valley rafters. And once they are all selected, I'm going to use mirror by drawn axis up there on the ribbon, mirror by drawn axis. And I'm going to go over and pick on the edge of my ridge, at the end point of the ridge, and I'm going to mirror it, flip it over to the top side. So now we've got structure on both sides. Finally, the last thing I'm going to do here, and I'll do this in 3D because it's easier just to select what I want and forget what I don't. So that the freshly mirrored objects are still selected. I'm going to hold down the shift key so that I can remove the two valley rafters because I'm going to mirror the commons because I need them in these two bays, but I don't need the valley rafters. The valley rafters are all done. So I'm going to go back to holding down the control key here, and I'm going to do little crossing windows here to select these other. So I'm holding down the control key and do implied crossing, which is clicking and dragging from right to left. And just by orbiting my model around carefully, I can get to a position where I can strategically control and then implied copy or implied crossing select all of those. Should be 24 common rafters. So having selected them in 3D, I can revert back to my underside of beams view here, and I can mirror it around the ridge here, but on a 45-degree angle. So if I mirror it on a 45 angle, it's going to do the copying on a 45-degree angle, and voila, there's our other rafters. So there's our final destination with all of the rafters created. Now you guys don't have to hand this in until next week. I forgot to put in the ridge beam here, so I'll just go back to the south elevation and show how that's done. So what we're going to do is, in our south elevation, there is the beam at the bottom. I want to put that beam up here at the center. So I'm just going to use the copy command to do that. And I'm going to copy it from the center here, and I'm going to move it up to the ridge. So there it is. So you'll need to do that on your south elevation and also your west or east elevation to get that thing So we've got that beam up there. Oh, I'm looking in the notes or in the picture there, and I realized that this beam is actually not under the joist, it's up here at the top. So I just move your beam after you've copied it. Just move it straight up like that. That's good enough. You guys will be able to see this on video later. So there you go, there's our beams. So you guys can hand this in whenever you've got it done. And of course, this will be up on YouTube because I'll put it up as soon as I'm done here. And you guys will be able to have a look at it later. All right, that's that. Now, quiz time. Now you guys don't have to do the quiz here. You can go home and do the quiz. You've got 2 attempts, so you can try it once tonight if you're feeling ambitious. It's open for a whole week, so you guys can do it tomorrow night and do it again on the weekend. Again, don't collaborate. You're supposed to do this, keep your answers to yourselves. Here is how you get to the quiz. So you can do this off-site. So you go to learn.bcit.ca, learn.bcit.ca, sign in with your username and password. Okay. So we've got these, find your course number, so you'll see it here. Most of you, it'll be 36581. There'll be a couple of you that'll be this number here. But whatever, it's the 2019-30 term. Look for the 2805 course, go in and enter it. And then under activities and quizzes, find quiz 1. It's open book, and you can see you guys can work on it until October 3rd, so next Thursday. So go ahead, go in and start working on the quiz, so you can work on each one. When you're done with the quiz, hit submit at the end for your attempt on the quiz to be saved. You have 2 attempts on the quiz, and at the end there's a practical exercise. And to do the practical exercise, you're going to need an AutoCAD drawing, which is in the Share Out folder for tonight. So if you folks go to the Session 3 folder, you're looking for an AutoCAD drawing called site_model. Site_model. You're going to need that, and you're going to need Revit on your computer so you can do the work and calculate, give the numbers that are required by this quiz. So you're going to build a topographic model, and you're going to do a little graded region on it to calculate the amount of cut and fill on the site. So you need this AutoCAD drawing so you can import it into Revit and build a topographic model for the final answer. So what you're going to be calculating is the cut volume, the fill, and the net between the two, and also giving me the area of the site using the property line tool. It is called site_model. It is in the Session 3 folder. I'll show you folks. Oh, it's outside, so it's in the BLDG. Okay, so folks, here I'm just going to show you where it is. So Share Out, BLDG, 2805. There it is. So it's right in the root directory of the 2805 course, site_model. You need that DWG. Take it home. Doesn't matter what version of Revit you're using. You got an older version of Revit? That's fine. You don't need the latest version of Revit to do that question. If you're having any problems with it or you're getting confused, just email me and we'll try and get you sorted.
Can you go back into the website and learn something?
Yeah, we're there.
Learn.
Yeah, learn.bcit.ca, we're there. All right, so that's it, folks. You guys are free to go.